class, we got you. Wherever you want it from, we got what you need. Don't get online class, we got you.
Good day, everyone. Good day, viewers all over the world. You are welcome to Traded Online Class. So today we want to talk briefly on special types of functions. Special types of functions. Of course, we know that a function is a relation in which every element is assigned uniquely. So if we assume let x and y, if we have assumed x and y to be two sets, so a function f from x to y is denoted as function x from x to y. A function f from x to y is denoted as what we have on the board, and is a set of ordered pair. So it's actually a set of ordered pair. So if you really want to know more about functions, the definition and interpretation of functions, you can check my video on mapping. Check my video on mapping. But today we just want to look at special types of function. The first one that we talk about are the polynomial. They are called the polynomial functions. Polynomials. They are called the polynomial functions. So in this case now, we have under polynomial function f of x, the function is defined as, in general, a naught s raised power n plus a1 s raised power n minus 1 plus dot 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 plus a raised power n, where a naught must not be equal to 0. And n, in this case now, this is what we are trying to say, that under polynomial function, we can have the value of x to be up to order n, but where a naught must not be equal to 0. Once a naught equal to 0, then s raised power n vanishes. So in this case now, n is called the degree of the polynomial. In this case, n here is called the degree of the polynomial. A specific example of this is when we say f of x is equal to s squared, 2s squared plus 3s cubed minus 4s squared plus 8x minus 1. So if you have this type of function, this is referred to as a polynomial function. This polynomial function of order 4, the highest order here, degree is 4. If the highest degree is 3, is cube, then it is order 3. If the highest degree is square, it's order 2. Then if it's linear, the highest degree is 1. Just that's the linear function. Square can be quadratic. So this is an example under a polynomial function. So that is that about polynomial function. So we can also have the second type of function, which is referred to as the exponential functions. Under this now, under exponential function, we can have f of x to be equal to a raised power x. And of course, from the word exponent, it simply means if you recall indices, when we have a raised power x, this x can be referred to as the power. We can call it power, or we can call it index, or we can call it exponent. So these three terms can be used interchangeably. So under exponential function, we have something raised to power of a particular variable. So that is what we have under exponential function. And there's this exponential function actually obeys the law of exponent, the law of indices. It obeys the law of indices. And there's an important, a special function of this kind, where we have a to be equal to e. And the value of e, you can actually check that in your calculator, exponential is 2.718, blah, blah, blah. It continues in that order. So when we have f of x to be equal to e raised power x, this is a special type of exponential function where this is called this is natural. So e raised power x is a special types of exponential function. We have so many exponential function, but when f of x is equal to e raised power x, is important, and it's a special types of exponential function in mathematics. So let's note that. Then we can talk about the third types of function, These are called the logarithm, logarithmic function. These are functions that has to do with logarithm. These are functions that has to do with logarithm. For instance, when f of x is equal to log x base a. So when we have function of this kind, so this is a function, they are logarithmic functions. So we should be able to know this. And of course, there's relationship between this and index. So if we have this now, so then if a raised power x is equal to y, then our x can be equal to log y base a. Our x can actually be equal to, if a raised power x is equal to y, then x can be equal to log y base a. So please, if you want to know more about this logarithmic function, check my video on logarithm. That will actually that actually explains more on this concept. But I just want us to be familiar with this function when we have something in form of log. Then there's this special types of logarithmic function where we have f of x to be equal to log x base e. So in this case now, the a here is referred to as e, is exponential. Then this same thing as nx. So it's a natural logarithm. So this is called the natural logarithm because x, this is the natural logarithm of x. So when this base is e exponential, then it becomes in x and is a natural logarithm. So we should note that. Then the fourth type of special function that we talk about, they are called the trigonometric trigonometric functions. That is, of course, we are familiar with some of these functions. So this is where we have y to be equal to, this is where we have y, we can have y or f of x. We can have f of x to be equal to either sine x, it can be equal to cos x, tan x, cosec x. We can have it as cot x, and we can also have it as sec x. And of course, if you want to know more about this function, just check my videos on trig. This is sine of the function, cosine, tangent of the function. This cosec is reciprocal of sine. Cot, that's cotangent, is reciprocal of tan. Y sec is reciprocal of cos. So if you really want to know more about this function, you check my videos on trig. Check my videos on trig. Then please note that sine x is same thing as cos pi all over 2 minus x. Please, you should know this. Also, cos x is equal to sine pi all over 2 minus x. That is, pi in radian is 180. 180 minus divided by 2 is 90. So sine x is same thing as cos 90 minus x. For instance, if x is 30, then here we are going to have 90 minus 30, that's 60. So if you check from your calculator, sine 30 is the same thing as cos 60 and vice versa. So if you have any of these functions, they are referred to as trigonometric functions. And you should also know that trigonometric functions are periodic. They are periodic. Like this sine and curve now. Sine and curve have period of 2 pi. So when you check their curve, if you check their curve, they have period of 2 pi. That is, this is the curve of sine. Sine is in this order. This is sine. Let's say x. This is for sine. Then the cosine is of this order. So trigonometric functions are periodic. This is sine curve. This is cosine curve. So this both curve, the only difference between this is phase angle. That is, if I decide to shift the origin in case of sine up to this place, up to this point, I'm going to get cosine. So trigonometric functions are periodic. They are periodic functions. Then sine and curve are of period 2 pi. Pi is 180, so that's 360. No, this is 180. This is another 180. So this completes the whole revolution here from origin. This 180 back to 180. This plus 1 minus 1. So trigonometric functions are periodic. Then we talk about the fifth types of functions. Then the fifth type of functions, they are called the inverse trigonometric functions. Trigonometric functions. So this inverse integrated function, we have something of this nature. If f of x is equal to arc sine of x, we can have arc cos of x, we can have arc tan of x, we can have arc cot of x, we can have arc sec of x, and of course we can have arc cosec of x. So these are inverse trigonometric function. Then we should know that if sine x is equal to y, then if sine x is equal to y, then x is equal to arc sine y. Just note that if sine x is equal to y, if sine x is equal to y, then x will now be arc sine of y. So these are examples under inverse trigonometric functions. So you should be familiar with all these functions. Then the last function that we are going to talk about in this class is the last function, which is the sixth one, are called the hyperbolic function. Hyperbolic functions. Of course, we are familiar with hyperbolic functions. We are familiar with hyperbolic functions. These functions, they are defined in terms of exponential functions. Under hyperbolic functions are defined in terms of exponential functions. The first one is Chan. The first one in this hyperbolic function is called Chan. Chan, we can say Chan x is same thing as e raised by x minus e raised by minus x all over 2. That is Chan. We can have Cosh, and this is defined as e raised by x plus e raised by minus x all over 2. That's what we have. And we have the tangent of it also. Tang x. And of course, this same thing as sine all over cos. It will be e raised by x minus e raised by minus x all over e raised by x plus e raised by minus x. You know, tan is same thing as shan x divided by cos x. And of course, we have cot x. This is same thing as reciprocal of chan x. Then we can also have sec x is same thing as reciprocal. Is the same thing as reciprocal of cos. That is, we are going to have 2 all over exponential x